Hello, I thought I might show you some of the software side of things that I did some work on a while ago to control this farm rover and get it to drive around, using GPS and do some autonomous driving. So this is kind of the first steps of that. I actually did this, only spent about a day and a half on it so far, about a month ago, while I was waiting for the postman to bring me stuff that I needed to get on with the actual driving of the chair. So in this video, probably the first half of the video, or the middle half of the video maybe, is going to be footage that I recorded a month ago from tests that I did back then, and I actually edited the video and everything, but to try and keep everything in chronological order, I thought I would get the chair running first and then show you this video after that. So anyway, here we are. And I won't go into too much of the details of how this is all done behind the scenes because there's quite a lot more to it than a simple Arduino sketch. I'll just give you a very brief overview right at the end of this video, I think, of a little bit of how it's going on. But for most of this, we'll just look at what it does and see how it works on the surface. So here we have a web page, and this is a Google Maps JavaScript sort of display. Over there we have a latitude and longitude, number of satellites, and a timestamp showing when that this data here was recorded. And there's a couple of checkboxes where you can make a selection there as well. And unfortunately I can't zoom in any further on the map than this, I can only zoom out. But what we're seeing here is this little red circle, oblong thing with the yellow wheels is the wheelchair. It's a little icon I made. You can actually make your own icons for Google Maps to do this. And I've split up the Earth, or the lat long, into a grid of 1 meter, approximately 1 meter squares, and it turns out you can do this quite simply just by truncating the lat long and throwing away the last, I think it's the last 3 decimal places. Whatever the GPS gives you, you throw away the last few digits and you'll get a fairly simple way of partitioning everything into approximately a 1 meter by 1 meter squares grid. And you can actually see, you might not be able to see, but they're not exactly square because we're quite close down to the bottom of the Earth here. So if you were at the equator, these would be nice, equal-sided squares. But down here, the vertical is going to be a little bit taller. But that's fine. And I'm only drawing the left side and the bottom just to save a bit of time because JavaScript on this map is not the fastest of rendering APIs. It's not bad, but there are a lot of these little squares to draw as we grow and drive the wheelchair around the place. So what it's doing is every time it goes into one of these 1 meter squares, it's going to mark on the map that it's been there. So you can see here, it's actually managed to go from here to here without going across any of the squares in between. And the reason it's doing that is because it's not actually getting the proper values, because it's not actually here. It's here, inside this corner room of my house, down on the floor. So it's quite impressive that it's getting 9 satellites there at all, but obviously it can't see any satellites in this direction through the roof of the house. It's probably just getting some signal coming in through the window, mostly from this northern side, which is, I'm guessing that's why it thinks it's more towards the northeast than it is, northwest, sorry, than it actually is. I'm not sure. But anyway, these little green squares are recording a history of every place that the wheelchair has moved to. And it will only do that while this checkbox is on here to register new locations. So that lets me move it around without having anything added to this history if I don't want it to. So the point of doing this is to drive the wheelchair around the place and let it build up a history of the places that it knows it is able to move to, and then it can use that as a database to do a search on. For example, if you say if it was actually here and you told it to go here, it knows that it can't go through this fence, for example. This is what I'm hoping. So it will go over here and around there, and it will know it will be able to find a path to get to where it needs to go and go there autonomously. So we don't have many cells in the grid here at the moment. This has just been running for about 30 minutes. I set this up before the video. I deleted all of the data in the database, but we'll have a look at me making some data, some more interesting data than this in the database shortly. So all of this stuff here is running on the Orange Pi, and I'm running everything through Wi-Fi to start with. I'm not going to bother with any NRF24 modules or tricky stuff like that because the Wi-Fi is just so goddamn easy to use, and as long as I'm within a reasonable distance of my house, I will be able to use it. Up to about here, I think, starts to get sketchy from that sort of distance there. But it just makes everything so easy to use it, because I can just log in on a Linux terminal and I can sit here at my desk, and even if the wheelchair was out here in the front yard there, I can still edit files and compile the program and start and stop things and everything. So for now it's just running totally on the Orange Pi, and no tricky radio protocols or anything at the moment. So this is the terminal, and as you can see, there's nothing happening. Nothing has changed while I've been blabbering on about this. But if we let's see, how do we do this again? I think I just call it test at the moment. But we can start up the program. So this is just a command line program. You'll see this change here in a minute now. So it's updating with the current data, and you'll see also there that the icon has moved. So now it thinks it's there, which actually, that's pretty good. That is exactly where it is, by the way. That's exactly where it is. Very impressed. This is a M8N, uBlox M8N module, my favorite. They work really, really well. But anyway, you can see that I think this is about 5 Hertz. Yeah, that would be right, wouldn't it? So it's getting updates 5 times per second, and it's writing these to a database, only if it's a location that it hasn't seen yet. And then it's updating the map, so we can see some more of these little green squares showing up there as we've been watching. And I can shut this down. I have not written a startup script for this, so ideally this would start up if the server was shut down and restarted. It would just automatically start again. But I haven't done that because I keep forgetting to do it, and also, as I found out driving around today doing some testing, the connections, if they go over a bump, they can disconnect and the server will reboot. And it's actually beneficial for me to know if that happened, because then I'll know that my wiring needs to be made a bit more sturdy or robust and reliable. Whereas if this program started up by itself automatically, I wouldn't actually know. Well, I could look at the server's main logs and everything, but I wouldn't actually realize that server reboot had happened. All I would see is a missing gap in the data, and I would think that it was a GPS problem, probably. So anyway, we'll see a little bit more about that later on. But for now, I'll just show you the video that I recorded using this to do some initial testing about a month ago. Okay, now I've placed the Orange Pi outside on the fence post at the front of my yard, which is just here where I have the cursor. And I've been running it for about 10 minutes or so, and you can see that even outside with about 9 or 10 satellites, it's not actually that accurate. Sort of wandering around. It's not as bad as it was before, of course. And the center is roughly in the right spot, so the center of this green patch. It's probably about 5 or 6 meters off right now. But most of the time it's closer to where it actually is on the fence post. So what I'm going to do now is I'm going to go out and pick it up, and I'm going to walk around outside my perimeter of my yard around this fence, and we'll see how accurately it follows it. And I won't be able to see this while I'm doing it. Oh, actually I could take my tablet out and I could watch it on my tablet, but what I'll do is I'll leave this running on my desktop computer that I'm recording right now, so that you can see how this display moves as I walk around. But I think what I might first do is just get rid of the current data that's in there, like this. So if I delete all of those grid rows from the database, we'll see next time this updates, that patch of green will disappear. There we go. Okay, let's go for a little walk. So I'm just going to follow the fence. I'm not expecting the locations on the map to line up, or the grid points on the map to line up exactly with the aerial photo. But what I'm hoping is that the overall shape of the fence line will match, even if it's offset a little bit. Anyway, so I'll just go for a little walk. I think I'll speed up this part of the video so you don't have to wait through it, but I'll catch up with you in a few minutes. Alright, well that's one circuit of the yard, And I think while I'm here I'll also go down that road and over there a bit, and maybe a little bit further up as well. And as I do that, at some point we're going to lose contact with the Wi-Fi inside the house, but that's not a problem because the database and the web server is all on here, so this within itself will be able to record all of the points. It's just that the desktop computer inside will not be able to show any updates for that immediately. So what should happen is that when we come back into range of the Wi-Fi inside the house, it should display the missing parts that were recorded while it was out of range. At least I think that's what should happen. So probably about here we're already starting to get out of Wi-Fi range, I would imagine. So let me just go that way. Alright, so I'll just stop between these two fence posts here for a minute and go back. Okay, let's go up that way. And this is actually going to be off the map on my desktop computer, recording it, and unfortunately, so you won't be able to see this as it happens. I'll have to shift the map over when I get back inside. Alright, there we go. Now let's go back inside and see how it turned out. Okay, how did we do? Looks like the perimeter of the yard is not too bad. This side's a bit wonky. We completely missed a section here. I have it set to a minimum of 6 satellites, so you need 6 satellites before it will record a point. So I guess at this point we actually did not have 6 satellites, maybe because of the tree there. Looks like everywhere else we're in the clear though. Looks like a missing spot there as well. This part of the road seems to match alright. Oh wow, there's quite a few missing areas there. Another patch there. What about this point? Looks like the location is pretty good there, but along this road, wow, that is not even close. That's got to be a good 5 or 6 meters off, I'd say. How far did we get here? I don't actually see that watering trough. That should be about here. Maybe that's a new one. It's not on the Google Maps yet. Anyway, that should give you an idea of what sort of accuracy we're dealing with, and hopefully it was updating fairly well in real time, at least when I was close by the house. Now, to be honest, I was not very thrilled with those results, and I was using a Neo 7M GPS module, so I thought I'll use one of the M8N modules, which are considerably better in reception and stuff. So I hooked up an M8N module and went to do the same test, and I left it sitting there for a while, and I noticed that it was almost as bad as the 7, and I thought that's a bit strange. So I decided maybe it was getting interference from the Wi-Fi antenna, which was admittedly very close to it on the top of the little box there. So I separated the GPS module and away from the Wi-Fi antenna, probably about 40 centimeters or so. And now, look what we've got this time. I have been running it for about 10 minutes here, and all it has moved is, well, if we look at the database, it's only generated 6 grid cells, and each grid cell being a meter means it has moved less than, well, you can see 1, 2, 3, 4, 5. I can't quite see where the 6th grid cell is, but it's been within 2 meters of that same point for 10 minutes, and that's only with 11 satellites. I also thought the number of satellites was a little bit low. It's still a little bit low. I'm sure this module can do better than 11. But anyway, I will do this test again with the M8N module, and this time I'll keep it separated from the Wi-Fi antenna by about 40 centimeters or so, and let's see what the results are with that. Oh, now we're talking. That is way, way better. Unfortunately, it looks like it stopped at this point, and if I just look at the console of the browser, it says failed to load resource, connection reset. So I guess we're just lucky that we did not have that last time. Not really sure why it didn't come back, but I think if I just refresh this page, it should come back. And sure enough, we can see the whole thing, and we still see the timestamp being updated occasionally there. But let's have a look at this. Obviously, we can see those lines are going very, very nicely along the roads, but even these little bits around the edge, the perimeter of my yard, it's right on the fence line, so it looks like the aerial imagery is actually pretty accurate in this location. And you can even see a little bump where I've had to go around the tree trunk there. And here I've had to come around the shed. You can see all these little deviations. And here again I had to come around this tree. So even those tiny little movements, well, it's a meter or so, they are showing up very nicely. And here I deliberately, when I came back here, I deliberately came closer to this side of the gate than that side just to see if it showed up, and it does. And then here, going down the road, it's not quite on the photo, but the outward trip and the inward trip, the return trip, are almost on top of each other. And along here they definitely are on top of each other. And over here I did this little curve like that. That's exactly the way I walked, this curve. And this one here looks like it is exactly on top of the inward and outward paths are exactly the same. So that is really, really good. I'm much happier with that. So I'm going to stick this on the wheelchair and drive it around now. It's all electrically separate from the wheelchair, but in theory it would be quite easy to do away with this USB power bank and power it from the chair itself with a 5-volt step-down regulator. It would be pretty easy, but just for now I like to have it in this easy format where I can pick it up and take it off later on, bring it inside to work on and stuff. Okay, so it's just stuck on there with some tape, good old sellotape. Great, isn't it? So I just did the same thing except with it on the chair. This way it will make absolutely sure that the GPS is not going to go anywhere that the chair itself cannot access. And you can see I'm taking a bit of a wider berth around some things that could get in the way of the autonomous pathfinding in the future, like these little trees here. It'll just make it easier if I don't try and tell the chair that it can go right up against the fence there. Now this kind of complicates things because I don't trust it to get through either of these gaps, which are only about 1 meter wide. So I think I'll just edit this later to cut this section off so that it can't come through here at all. It's going to have to go, if it wants to go from here to there, it's going to have to go all the way around the house to get over there. It's just too bad. I also took it up and down the road a little bit along the edges of the road, so up one side and then back down the other side of the road to try and get an outline of like the width of the road. Now just before I drove this in the garage to put it away, I have to remember to turn off the register new locations checkbox, and just to double check that it's not recording where it is right now, I drove it to an area where there's no marks, no squares on the grid, just there. And we can see that it's not recording at this point, so it's safe to drive it into the garage, because I don't want it to record any points inside the garage there, otherwise it might try and drive in there. By the way, if you're wondering what this light on checkbox was on the control panel, This is for turning a... Yes, you took the words out of my mouth. Very good. It's for turning a light on. So if I check this checkbox here, we'll see a big light there. I'm just powering this from a LiPo at the moment, but it will be powered from the chair's battery, of course. It can do, I think it can go up to 30 volts, this one. It's a big LED thing that you get for putting on your car or something like that. But it's reasonably power efficient and quite bright. It's just running on 4S at the moment, but when it's on 24 volts it should be a bit brighter than that. It's not really dark yet, so it doesn't look so impressive right now, but it's pretty good. I think it'll be just fine for driving around FPV. And these statuses here, by the way, they are actually written to the database before they get extracted by the program that's running on there, so that what that means is that the state of everything, if the power gets cut off or something, the state of what it was doing last time will be restored when it starts up next time. Nice thing about that is it also means that if you have multiple of these control panels running, because that status is sort of synchronized in the database, it means that if I turn one of them off, the other one will be able to update its control panel to reflect what's actually happening. So this control panel, these checkboxes are actually showing you like a current status. So it's not just an input to control it, it's a current status showing you what's going on as well, even if somebody else at one of these other endpoints has changed it. So let me just change it on my tablet and you'll see it change on the phone as well. And the light goes off. There's a little bit of a delay because, like I said, it's only updating this page or only pulling this data every few seconds or something like that. I forget what it was. It's been a few weeks since I made this, but you can see that the status will be reflected across all of these like that. A little bit slow, but that's the way it has to be. I just realised that I kind of glossed over an important point here, but that is, of course, you do need a great big transistor in between your Orange Pi and the light to get this to work. So I got this transistor here, which is I forget what the model number is, but I'll put that on the screen if I remember, and I think it can do up to 60 watts. This light is a 28 watt light bulb, so I figured that should be alright. And yeah, it gets pretty warm, so I've only had the light on there for about 30 seconds, or just before I started recording this little clip of video I turned it on, and it's already getting pretty warm, so I think it's going to need a heatsink. Actually, I found that I can hold this transistor in my fingers indefinitely without feeling any discomfort at all, so I don't think it really needs that much of a heatsink. Maybe I would get away with nothing. And here's the result of that. So you can see I have gone around my house. Actually, it's a bit hard to see what's going on here and which is like the interior lines and the exterior lines, but this is the garage outline here. That's the house, and I also drove around and around the clothesline post, but you can't really see where that is. So the resolution that we're getting here is really not quite good enough for what I'm trying to do, so don't worry, I'm under no illusions that this is going to work out perfectly well with the current level of detail of grid that I'm using. But I have an idea that may be able to improve on this. It's just a matter of money, really. But anyway, it's reasonably accurate. I was a little bit worried that having it sitting right on top of the batteries might influence into something, but I guess it's only the magnetometer that's going to be influenced by that. The GPS should be okay, but all the same, it doesn't seem to be quite as accurate as it was when I was walking and holding the GPS at least 40 centimeters away from the Orange Pi. Just go down this road a little bit to show you what that looks like. It's not bad. It's usable. So the next step is to do a little bit more work on this interface. At this point, what's needed now is a way for the user to say this area here needs to be filled in. So it's just going to fill this whole area with grid cells so that the rover knows it can go in any part of this region here. And after that, I would also like the ability to be able to delete cells by hand. So right about here, I would want to take some out so that it can't go through. As I mentioned before, I don't want it to try and go through the area where there's that silly gazebo thing there, just in case it hits and drives and probably knock it over. It's it's on its last legs like everything around here is. And And after that, I guess the pathfinding code needs to be done. I've done all this kind of thing before, by the way. I'm no stranger to grids and pathfinding and everything like that. I'll just show you the screenshot here that I have from a really, really old game that I was working on ages ago just as a hobby project. But it's the same sort of thing. You start off with a grid. In this one, the yellow parts are walls. So, and it's using portals or partitions or something like that. I can't remember exactly. But what I'm thinking to do is do just the normal A-star pathfinding to get from start to end, and then do this kind of a string pulling. I don't know what other people call it. I call it string pulling. You just, at each point, you take a line of sight check to see if you can get to the next point. 2 points past it, and if you can, then you remove the point in the middle. So instead of going along a jagged sort of a square grid path, you end up with these more natural looking straight lines, and you can go a much more direct route. So that's one thing I'll be doing, hopefully. Maybe not straight away, but eventually I'll try and do that. And another thing I'll do, just to be on the safe side, is I won't let it go into any of these exterior cells. So where the boundary is that I just defined, that would be given a level of, say, 0, meaning that there are meaning that it's on the outside of the boundary, and then the cells inside that would be a level 1, meaning that they are one level or one cell away from the exterior border. And then if you do that and you say that your pathfinding algorithm is only allowed to traverse cells that are of level 1 or greater, or level 2 or greater, or so on, that should avoid the problem of coming right up close to the edge of something. And for example, you come around this corner, you might crash into the fence just as you're trying to go through the gate. Unfortunately, there's only one. It's a bit tight there, isn't it? Yeah, so this whole grid that I'm using, it's a good start, but I think ultimately it will need something a little bit more accurate than this. But anyway, that's the current state of things. If I make any more updates, I'll let you know in future. And just before I finish, I did promise to say a little bit about what's going on inside the Orange Pi. I don't want to explain it in too much detail because it is pretty complicated, but I'll show you this diagram and give you a little brief overview. I don't really know if I'm going to keep anything like this. This is just what I have at the moment. I'm not saying this is a great way to do it. But we have the wiring Pi program. This is the command line program that I showed you earlier in this video. It's running in C++, and it's reading in data from the GPS, and it's also switching one of the GPIO pins off and on to control the light. And it got pretty complicated quite quickly because it needs to keep a queue of these GPS data's coming in so that it doesn't skip any, because it needs to send them to the web server. I'm using the curl API to contact the web server through this arrow, and it needed to have a separate thread to do that. So there's a thread to do that, and then there's a thread to ask the web server what is the current state of the lights on checkbox and the register locations checkbox. So all of that data, even though it knows it's asking to get it from the database, just in case one of the other controllers, so that's these web browsers here, somebody else might have changed it in the meantime. So it needs to have a thread to pull that data from the web server as well. On the web server, this is just a collection of PHP scripts, not much of a brain there. It just sort of relays the data and puts things in the database. And so these arrows here, current status and control inputs, are both going into the database and out of the database. The database format is pretty basic. To store the positions of the grids, I haven't used any of the geo features that some of these databases have. I'm just using a plain old table with 2 columns, one for lat and one for long, and I'm just storing a grid cell as a row in the database, and I'm using the replace into syntax with a unique primary key to make sure I don't duplicate any grid cells, so it's not going to grow obscenely out of control. Each row in the database will be a unique grid cell. And to draw the stuff on the map at the moment, I'm just doing select star from the grid table every time it wants to draw, every time a new cell has been added, which is a very, very inefficient way to do it, especially when you're trying to draw it with JavaScript. So a lot of the stuff could be made much, much more efficient, but it's kind of working at the moment, so I'm just sort of keeping it as a very basic prototype at this point. So that pathfinding stuff that I was talking about before, I think is probably going to have to go in here, but I don't want to slow it down too much, so I'm actually thinking about making a separate module or a separate C++ program, or maybe even PHP, I'm not sure. But I'll let you know a little bit more about this as I work on it and figure out what I'm going to do myself. Anyway, that's all there is for now. Thank you for watching, and I'll see you next time.